Okay, the last class, what we did, if you see the last two classes, we we saw what are the fundamental quantities and derived quantities, and then we saw the three common, the most important fundamental quantities. That's what? That is these three, correct? Length, mass and time. Okay, so these are the fundamental quantities. Okay, and then we had the derived quantities. Okay, derived quantity example is acceleration, momentum. Okay, the units of those derived quantities can be expressed in terms of the fundamental quantities. Okay, we saw in MK system also, sorry, in SI system, this will be length is in meter, kilogram, second, Kelvin, and go on, right? We saw all those things. And then we saw in the previous class these three important fundamental quantities, that is length, mass and time. What are the way how we are defining the unit of it? Okay, how did we define the unit of those fundamental quantities and all? We saw something about Kibble balance and all, right? Those things we saw. And then towards the end we said something we will look in the dimensional analysis. Okay, so first, and this is a very important aspect in the physics. Okay, even in the later, even up to PhD or something, this is a one technique or it's a one tool which is very handy for almost all physicists. Okay, we will see it's what. First, what do we mean by a dimension? Okay, the dimension is, so what we, if we remember, any derived quantity, a derived quantity can be expressed in terms of the fundamental quantities. Okay, so when I express any physical quantity, say acceleration or momentum or whatever you say, okay, or energy, okay, all this term or force, you can say, all this term can be expressed in terms of the fundamental quantities. Okay, so then, so this forms, so when I express, so for example, let us take example that will make it easier. Let us take acceleration. Acceleration is what? Rate of change of velocity with time, right? So let us call it as v by t. Okay, and we know the what is the unit of it? Velocity. Velocity unit is what? Meter per second, correct? So this will be meter per second. Okay, second divided by time is second. So this makes it meter per second square or meter minus 2, correct? So then, so acceleration is a one physical quantity which can be expressed in terms of the fundamental quantities. So then if I want to, so then acceleration, I can always, the dimension of acceleration I can say, so let us, the main important thing is the three fundamental quantities let us write. So let us write it as L for length. Okay, I am going to use L for length and M for mass and T for time. So I am going to write it as L, M and T. Now you see, so the length will be, where is the length here? This one, correct? So the, what is the power of length? M square or M1? 1, correct? So this will be power of 1. So is there a mass there? So the mass will be power of 0. So mass is not there. Is there a time? Time. So time power is minus 2. Then I put a square bracket. So length is the unit of for acceleration. Length is 1 unit, mass is 0 and time is negative minus 2 to a power of minus 2. Okay, so and this you call as a dimension of acceleration. Okay, so let us take one more example. Let us take density. What is density? Mass per unit volume, correct? So that is mass by volume. So what will be the unit of it? Mass unit is kilogram, correct? And the volume unit is, volume is in meter cube. In SI units, we have to write meter, not centimeter. Okay, and the mass will be in kilogram. So the unit of density is what? Kilogram by meter cube or kg m to the power of minus 3. Therefore, the dimension of density will be what? So first you have to write L, M and T. Now tell me what is the power of L? Correct, minus 3 because this is a minus 3 meter, correct? And M? 1, very good, because kg. Okay, is there any time? So therefore 0. So this is the dimension of density. Okay, so and correct. Okay, so then what happened? That they have a definition. There's a definition in your book, but the definition is in a very horrible way it is written. Okay, if they are on the exam, you may have to mug up and write. I don't know, otherwise they will give. So dimensions of a physical quantity. So the dimension, these are the physical quantities. Okay, so what is the physical quantity they have written? So here we have taken the two examples of two physical quantity, right? Density and acceleration. You can do many things like energy, force, anything you can do. Okay, all physical quantity, whatever we are doing. Even when you have a current, you can have the voltage, power watts, all those things we can write because that is also one of the fundamental quantity. Okay, so the dimensions of a physical quantity are the powers to which the concerned fundamental units, correct? The dimensions of a physical quantity are the powers to which the concerned fundamental units must be raised in order to obtain the unit of the given physical quantity. You got it? So these are the fundamental quantities, the power that should be raised in order to get the unit of the physical quantity. You got it? Similarly from here, we took it from here. Okay, so I read the line again. The dimensions of a physical quantity are the powers to which the concerned fundamental units, these are the fundamental units, right? Fundamental units these are, must be raised. What's the power? Raised. Okay, minus 10 power, L to the minus 3, 1, 0. Must be raised in order to obtain the unit of that physical quantity. You got it? So, and that's what your dimension. Okay, so there are many, similarly you can, so I give an illustration of acceleration and density. You can do it for velocity. So tell me what will be the for velocity? Velocity will be simple, am I right? Because anyway, velocity will be what? Velocity is equal to what? By unit time, correct. So that will be, let us call it a displacement is d by t, okay. And the unit will be what? Distance is in meter by second. Therefore, the unit is meter per second or m is minus 1. So what will be the dimension of velocity? Tell me. First you have to write, simply first write L, M, T. Then put the power. What will be L to the power? 1, correct? M, is there a mass? 0. And time? Minus 1. Okay. So this is the way a dimension has to be written. Remember that. This is a square bracket. In between, put up the fundamental unit. These are the fundamental length, mass and time. And then write the powers of it. This is the way a dimension has to be mentioned. So this is what you call as the dimensions. Okay. So now once the very good thing in this, why this using this dimension is important is it makes sure whether your whole calculations is correct or wrong. Okay, not just that. Sometimes dimensions can give you an intuitive idea. Suppose you have some idea in physics, something, some phenomena you are seeing and you want to explain it. You don't know where to start with. You don't know how to equation to start with or something. So in those cases, this dimension, what they call dimension analysis, gives you an idea. What will be probably the equation will be. You got it? So you can find out the equation. We will see an example. So that's what dimension analysis is, a way in which sometimes it can be used in many ways to check whether your equations are correct or sometimes you can even derive certain equations, important equations for physics, okay? But that is not always correct. Dimension analysis is a kind of a tool, okay, which should not be believed completely. It gives you an idea. Probably this may be the way. Okay, so once you got an idea, then you can perform an experiment and check whether what the idea you got it is correct or wrong. Okay, so always the dimension analysis has to be supported by an experiment. If you don't have an experiment, the dimension analysis will not be useful. Okay, so and we will see about this dimension analysis. That is more interesting. So let us step by step how this dimension analysis will be useful in the when you are dealing with physics problems. Okay, so first, this ink is getting dried up. So first, to change the ink. Okay, so now you know what do you mean by dimensions, right? So now let us see, if let us write some equations. Okay, now I'm giving you a simple problem. I have some stone in my hand, okay, and I'm standing on a first floor of a building, and or maybe on a 10th floor of a building. I'm going to drop that stone in the ground. And I'm asking, so from the 10th floor you're dropping the stone is going to cross one by one floor, 9th floor, 8th floor or something. Okay, then I will ask you after 2 seconds, where is the stone is? The stone will be in front of which floor? So then this is a physics problem, correct? So you have to find, I'm asking you a question because I'm throwing a stone. It's a physical happening, phenomena is happening. I'm throwing a stone is falling down. I'm asking you a question, so after 2 seconds, where will be the stone be? Okay, so then what you know, a simple thing is, you know your equations of motions, correct? So you can simply use the equations of motions with that you have done earlier classes, am I right? Okay, so which equation of motion you use? You will, since I'm asking about the distance traveled, okay, so you will use this equation, S is equal to ut plus half at square, am I right? Okay, where u is the initial velocity, a is the acceleration, in our case it is acceleration due to gravity, okay, and t is the time, and this is the distance. So in our case, what happened? So since I am dropping it, the initial velocity is 0. So this will be simply half at square, correct? U is 0, right? Because u is the initial velocity, t is the time taken, and a is acceleration, and s is the distance. So since I am dropping it, there is no initial velocity. So this u is equal to 0. I can easily remove this guy. So then your distance traveled, s is equal to half at square. Suppose you forgot this formula, okay, and you don't know whether you are not very clear about the formula. So instead of t square, you thought it is t. Okay, but you don't know idea. You have no idea what to be the power. You know that whether it is t is power of t is 1 or 2. You don't know what is the formula. You've forgotten. That time dimension analysis can help you. How? Let us see. Dimension analysis says any equation, the dimensions of the LHS should be equal to the dimensions of the RHS. Okay, so let us write down the dimension of LHS. LHS is what? This is distance. Am I right? The unit will be what? This will be meter. Correct? And this is a constant, no unit, of acceleration. Acceleration is meter per second square. Correct? So this will be meter per second square, and time, this is t. Okay, so the dimension of S will be what we write? LMT, right? We wrote LMT. Tell me, what will be the L?
L0.
Yes.
Okay.
L is length.
L1.
L is 1. Mass 0 and time 0. Correct? And let us take A. For A, what will be the dimension? Tell me. LMT. Okay. L will be 1.
Mass will be 0.
Mass will be 0.
S will be 2. Minus 2.
minus 2, correct? Minus 2, right? And then let us write t. What's the dimension of t? L, M, T. L will be 0, M will be 0, T will be 1. Am I right? So now, so what we have, S is equal to half AT. So this into this. When I multiply both, so therefore A half AT will have a dimension. I have to multiply them both, right? So L power 1 into L power 0, you know that, na? X power M into X power N equal to X power M plus N. Right? So the same thing. So L power 1 plus L plus 0, that will be L1. Correct? M power 0, M power 0. That will be M power 0. So what this will be? T power minus 1. Can you see? Are they both match? Okay. So they are not matching. So that means this equation what you have written is wrong. Okay. So from here itself you can get an idea. So now when this both will be matching? Yeah. So this has to become 0. Correct? Correct. So when this will become 0? If you do. So when this is, because why do you got is minus 1? Because you are adding this to L, t to the power minus 2 plus 1 minus 1. So you can clearly see this is something wrong. If I had it as 2, then this will become 0. Correct? Then this will become 0. So when this will become 2? T square. So when it becomes t square, then your time dimension will become L0, M0, t power 2. Okay, and then, so therefore, half AT square will be, dimension will be what? L1, M0 and t power 0. So you can got it? So therefore, the correct equation will be S is equal to half AT square. So you got the idea? So this is the very easiest way. So the dimension analysis. So even in the later on future also, any physical problem what we use, the first step is to always to check whether the dimensions on the LHS and the RHS are they both same. If at any part of your calculation, okay, remember, if at any part of your calculation, if you find out the dimensions are not matching, LMT, okay, we are using only 3 because we are using the basic fundamental, only 3 quantities. If you had a current and everything, then you have to use all these 7 terms come there. Okay, so but these 3 are the, as I told you earlier, these 3 are the important fundamental quantities. Okay, that's why we are sticking to these 3. Okay, in a later on class, you have to use other dimensions also. Fine. So in any part of your calculation, in the final answer, you started some equations, everything which was dimensionally correct, you solved everything, and finally you saw the final equation what you are getting. If the dimensions are not matching, that means you have done somewhere else wrong. Okay, and not only the wrong, it can give you an idea where it must have gone wrong. Because you know, to get this dimension, maybe one time is missing. So somewhere else I missed the timing. Okay, so this is an important tool to verify the correctness of your equation. So this is the first use of this dimension analysis. Second thing, let us go for the second problem. Second case is also very interesting. Okay, yeah. So this is a second, you don't know an idea what the equation can be. You have seen a phenomena, you have seen some phenomena you can happen, but you don't know what that how to express that phenomena in terms of equations. So in that case also, you can actually use this dimension analysis to get an approximate expression for the phenomena. And then you can do experiments and verify other things and all. Okay. So for example, that's what, let us take this funny looking pendulum. Okay. So for example, okay, the problem we are going to see is, this is a pendulum. Okay. It's a very pathetic pendulum. Okay. So let us start the pendulum. It's oscillating, correct? So I want to know the time period. What is the time period? It means time taken for one oscillation. That means it's going from here to here. What's the time taken? Okay. So now if I ask you on the, what's the time period, can you tell me?
I don't know.
You don't know, right? Anybody don't know. So how dimensional analysis can give you this way? So I know. Then what happened? I know is, see, when I oscillate, it takes some time. The moment I reduce the length of it, now it becomes faster, correct? Am I right? So that means it's going to depend upon the length, obviously, correct? Okay, so then what I'm going to write is, yeah. So what the dimensional analysis, so the time period, I want to know the simple pendulum. This is called a simple pendulum. So I want to know what I want to know. I want to know the time period, which I am going to denote it as T. I want to know the time period. So what I know, the time period depends upon the length. Am I right? Because I have seen that when the length is longer, it's taking a longer time. When I'm making it shorter, it keeps faster, right? So it takes shorter time. So that means somehow this is proportional to length. But I don't know which power of length. It can be L square or L to the power of -2 or -3. No idea. Okay, so what am I going to do? Let me write it as a alpha. Okay, this is the first one. Now, one more, what are other quantities I know? Because if this pendulum, for it to oscillate, if I take it to space, will it oscillate? Because why? There is a gravity, correct? Because of the gravity only it is there. So obviously there is a gravity is also one of the quantity. So let me write. So my T is proportional to gravity also. And I don't know what is the power of gravity. So I won't write alpha. Alpha will confuse you because the Greek alphabet. Okay, let me use it as A. And for gravity, let the gravity to the power of B. I don't know. And then my another intuition says, probably this screw is lightweight. If I make a big iron ball, very massive, then the time period may change. Am I right? So probably the mass also can play a role. Okay, the time period, I don't know. It can happen. I may have a lighter mass, the period may be slower. Okay, I may do the experiment, let's say, but before doing the experiment, I want to see the mass also may be an important factor, which is going to determine my time. So then I am going to write, okay, so let the mass, I am going to write it as C. Okay, so the proportionality. So this is all. And I don't find any other quantity which is going to be dependent upon. Am I right? Because the pendulum is so simple. It's the length of the thread, gravity is there and mass is there. Nothing else is there. Okay, you can take up the air friction. Now you cannot go and ask me when I drop it in the water and ask. Okay, so let us take a simpler case, not air. We will take in a vacuum. So in that case, this time period of the pendulum is going to depend only upon these three quantities, correct? I don't know what is the exact formula of it. So let us try to find out, using the dimension analysis, can we get an expression for the time period? So then let us go for that. So then if I write T, if I remove the proportionality constant, what I am going to get it will be some, so proportionality, if I remove the proportionality, what I need is a proportionality constant, correct? Let me call the constant as K. Okay, K, L power A, G power B and M power C. Now let us go with the dimension analysis. So let the LHS, time. What's the dimension of time? L, M, T. Tell me.
L0,
L0, M0, this is 1. Okay, and let us go for the L. So we have L power A, am I right? So L power A means what? L, M, T. L power A, correct? Because length is the 8th power. M will be 0, T will be 0. Okay, and let me go for a G. You know G is what? Acceleration due to gravity, correct? G power B. You remember what G is? Acceleration unit is meter per second square. Okay, meter per second square. So meter means length 1, time will be -2, correct? So L, M, T. So what have length will be B, yeah, because what happened? G, the dimension is meter per second square.
Ah.
Correct? So, therefore, G power, so G will have a dimension of G will have a dimension of LMT. So, L1, M0 and T minus 2. Correct? So, when I write G power B, everything will become B. Correct? So, then this will become B. So this is also to the power of B. Okay, you should remember the formula x power m power of n equal to x power m into n. Correct? So this will be LB, 0 into B is 0, m is 0. Correct? And this will be minus 2 into B will be equal to minus 2B. And then let's come for the last one. That is a mass. Right? M to the power of C. Mass is simple. So we have L, M, T. So for mass, there's only one, this will happen, right? So these two guys should be 0. So this should be 1. And now this is whole to the power of C. So this makes it a C. Am I right? So then, now let us try to find out what we are going to. Yeah. So right hand side is L power A. We have to multiply all the three. Correct? So we are having L power A, G power B and M power C will be equal to L power A, M0 and T0. Correct? L power A, M power 0, T power 0. And the next one is for G power B, L power B, M power 0, T power minus 2B. So L to the power of B, M to the power of 0, T to the power of minus 2B. Am I right? And then M power C. So M power C is what? L0, M power C, T power 0. Okay, so this will be L power A plus B plus 0. Correct? So this is going to be L to the power of A plus B. M will be what? 0, 0, C. Am I right? And then T will be what? Tell me. 0 minus 2B, 0. So it will be minus 2B. Correct? So this is the dimension of RHS. Correct? Right hand side. Constant doesn't have a dimension. Okay, this constant is what our assumption is. It may not be. We will see. We see that later on. So this is the dimension of RHS. RHS have this dimension. Let us see LHS dimension. LHS dimension is what? Is a time period. Am I right? So LHS dimension will be, it's a time, right? L power 0, M power 0 and T power 1. So what we said, the dimensions of both of them should match. That means A plus B should be equal to 0. C should be equal to 0. Minus 2B should be equal to 1. So what happens? So A plus B should be equal to 0. C should be, so this gives me A equal to minus B. Or B equal to minus A, whatever. Correct? C is equal to 0. And the last one is minus 2B equal to 1. Okay, therefore, from here, what you will have, so this will give me B is equal to minus 1 by 2. Okay, so now from here, A equal to minus B. So since A equal to minus B, that will be equal to 1 by 2. So we got B, we got A, we got C also we got. Okay, so then we can just simply substitute these values here. So the time period is going to be, so the time period will be K L power A. L power A is what? 1 by 2. 1 by 2. G power B. G power B is what? Minus 1 by 2. And M power C. M power C is what? 0. So 0 means, so M won't be there at all. Correct? Or this I can write it as, this equal to K L power 1 by 2 divided by G power 1 by 2. I can write it like this. Or I can write it as K square root of L by G. This is the formula for the time period of a simple pendulum. And if you actually do the experiment, this will be the exact formula. Okay, even though you hang on this thread and do oscillation, okay, the time period is not going to change. Okay, whatever it is independent of the mass of the blob, whatever the weight it is hanging. Okay, so it can be a very lightweight screw or a big metallic ball or a wooden ball, whatever you keep. Okay, the time period of the pendulum is not going to be dependent upon the mass of the object you are hanging as a weight. Okay, so you can do all the experiment and you can see. So now actually see, so this interestingly, you got an idea. So now you didn't do any big lengthy calculation or anything. Simple, you started with a simple pendulum, you assumed, okay, what are the parameters, what are the quantities the time period should depend upon. And then you just wrote them and wrote the power and you got the exact equation. Without going for any complex mathematics or something, very simply you got it on. Okay, this is the power of dimension analysis. Okay, so many times it gives you a very easy answer. Okay, but dimension analysis will not be complete. Because what I mean, say this one is saying, this is the intuitive. Sometimes, many times in physics, often the problems comes from the intuition. So here also, because we know the pendulum, we know our intuition says yes, this has to depend upon the length. Our intuition says yes, it has to depend upon the gravity. So this, when you want to combine your intuitions and you want to make a equation out of it, one of the important tool which is going to come handy for you is a dimension analysis. And that's what we did. Okay, and well, yeah, so but this is not complete, because the point is, because you don't know what this proportionality constant is. Now, dimension analysis, to get the proportionality constant, you have to do the experiment. So dimension analysis itself is not complete. It gives you an idea, and then you have to perform experiment and find out what is this value of k. Okay, and if you perform this experiment for a simple pendulum, what you will find is that k will be typically equal to 2 pi. So therefore, your time period t will be 2 pi root of L by g. So this is the formula for the time period of a simple pendulum. So this is the second application of dimension analysis. First one we said to check whether the equation is correct or wrong. Second, if you don't know the equations, if you don't know, you can always give an idea how to construct the equation. Okay, and the final, the other one important thing also is there, that is for the unit conversion. You remember I told you last time, there was I think one class I told you, right? There was an accident, there was a Mars orbiter which was sent by NASA, okay? So, which went and crashed on the surface of Mars. Okay, instead of orbiting, it went and crashed off. It was a huge money loss. And what is the mistake? The people, they made a mistake in conversion, because one was using FPS system, another was using SI system. Okay, in the conversion, they missed it. Okay, so okay, that problem is different. So what happened? Your dimension analysis also can give you an exact expression for the conversion of from one unit to another unit. Suppose you are given a calculation which is done in some FPS system or CGS system, but your rest of the calculations, all the calculations, what both of you and your girlfriend maybe later on. Okay, so you both are doing a problem, and stupidly she used CGS system. Okay, and you are using SI system. So then what happened? So then now, but you have to, if both of you has to do the experiment together. So you have to combine them. Either you have to convert into CGS system, or she has to convert into SI system. Okay, otherwise you have to keep fighting. Okay, so dimension analysis give you the dimension analysis give you a way to convert your units also. Let us see that how. So for example, let us take what the example given in a book also. I am maintaining the same example. You can do for any examples also. You can take it force, Newton, whatever it is. Okay. So the simple thing is, so let us take let us take energy. Okay, so in the calculation, so you have done energy. You have used the calculated energy in terms of SI units. You use the SI units. The other person has used the CGS units. So now you know how these two energies, so they both are different units. Am I right? So these units, because I said, if you remember in my first class, I told you, the units are just a convention. Your final physics is not going to change because of what units you are using. That's why I'm saying, if some alien come and he use a different units, which is none of these units, if you come and use a different set of units, the physics he is going to derive is going to be same. Okay, the physics will not change even with the choice of your units. Okay, so the point is this, only thing what happens, you have to give the conversion factors because you are using different units. Okay, so how to get a conversion factor? Again, your dimensional analysis will be very helpful. For example, let us take that, you and your co-worker has done some experiment and both of you are calculating some energy. So one of you have calculated energy in a CGS unit, another one of you calculated in a SI unit or MKS unit. So what happened in a energy, oops, spelling mistake. Energy, okay. So the unit is what? So if you call it in CGS, okay, what they call the unit we call as a erg, okay. In MKS or SI system, we call it in joules, okay. And what will be the dimension of energy? Do you remember any one of energy? Any simple energy? Kinetic energy? Or potential energy? So which formula you remember? Which is easier? Potential energy formula you know? mgh. You got it, take a mass, the height into the gravity. Okay, so let us try to see. That's a good example we can see. So the potential energy formula is what? mgh. Okay, the kinetic energy. What's the kinetic energy formula? Half mv square. Okay. So shall we find out the dimensions of the both? Okay, let us see whether they both are same. That's a good example you can do. Let us take the potential energy one. So what is the first one? Mass. Let us write mass. Dimension is what? LMT 0, 1, 0. Gravity. LMT L1 M0 minus 2. And H. This is LMT. Tell me what is the value? L1 0 T0. So what we have, so MGH will have the dimension of, you have to multiply all the three, correct? So L will be 0 plus 1 plus 1, correct? LMT, we are multiplying the 3, na? So this will get added up, right? 0 plus 1 plus 1, that is equal to 2. M. What happened? 1 plus 0 plus 0, 1. Time will be what? Minus 2. So this is for the potential energy, correct? So now let us do it for the kinetic energy. I am going to do for the kinetic energy now here. So here I have mass and velocity. Am I right? So mass will have, because half is a constant, doesn't have any dimension, it's a number. Okay, so what is the dimension of mass? LMT, tell me what it will be?
L0 F1
0. Okay, V square, remember. So first I have to write it as LMT, what is the velocity, and then the square here, correct? So what is the velocity, the unit dimension of velocity? Displacement by time. So it's basically length by time, correct? So length will be 1, time will be minus 1, correct? Mass will be 0. So now since the square is there, I have to take it inside, correct? So that will be L2 M0 T power minus 2. Okay, so mv square will be what? I have to multiply these two, am I right? So L0 plus 2 will give me what?
L2,
L2, this one,
M1,
M1, and what about these two?
T minus 2.
Are they both same? Magic?
Yes, they are same.
Correct? You got it? So this is an example. So energy will always have a single dimension. That's why the dimension is a physical quantity, because energy is a physical quantity. It is going to have a single dimension. The dimension is not going to change for energy at all. It will remain like this. Okay? So this is an example. Okay, so I can simply write down the dimension of energy will be what color I can use? Okay, let me use the blue only. So the dimension of energy is what? Tell me. The same thing, right? Either of this one. L2,
M1,
M1,
T minus 2.
T minus 2. So this is going to be the dimension of energy. Okay. So, and okay. So now what am I going to do? I want to find out from the CGS system to the MKS system. Okay. I don't know why they have written it like this. This is not a correct way of writing. Okay. So somehow I have to define the dimensions of it. Fine. So then I'm going to let us denote it. So let me write down L square M1 T power minus 2. Let me write this is CGS system. Okay. I want to define, so this is not going to be equal to SI system. There will be some factor, some unknown number will come, correct? That factor correction. And that's the number which they made a mistake and the Mars orbiter went and crashed on the Mars. Okay, so the X will be again same thing, because energy is same. Irrespective of whatever the unit you are using, the dimension is going to be same. Am I right? So this will be L square M1 T power minus 2. Correct? And this will be your SI. Okay, so then what will be your X? X will be this divided by this. Am I right? So this will be L square M1 T power minus 2. This in CGS divided by L square M power 1 T power minus 2. This in SI. So now, so then what happened? So so in CGS system, what is L square? Length is in what? How would you measure the length? In centimeter. So this will be centimeter square. Am I right? Mass will be in gram. CGS. Gram. Correct? Gram, power 1 is 1. And time is again in second square. Correct? So in the SI unit, length will be in meter. Correct? So meter square. Mass will be in kilogram. And then time will be second minus 2. So now you know how to convert a meter to centimeter, kilogram to gram. Correct? So what will become? So then I can write it as centimeter square, gram, second square. Let me convert. So this will be how much? Meter square will be how many centimeter? So tell me.
1 meter, 1 meter equal to 100 centimeters.
Correct. 1 meter equal to 100 centimeters. So 1 meter square will be, correct? So this will be 100 to the power of square centimeters. So that's equal to 10,000, or that I call it as 10 to the power of 4. Am I right?
Centimeter square.
Yeah, centimeter square. Sorry. Am I right? So this will be 10 to the power of 4 centimeter square. Kilogram. You want to write in gram. Am I right? That will be 1000. 1 kilogram equal to 1000 gram. Am I right? So equal to 10 to the power of 3 gram. Correct? So this will be 10 to the power of 3 gram. Second square is because we have to say the same second square. Correct? Second square. Sorry. S over minus 2. So this is going to be 10 to the power of 4 into 10 to the power of 3. X power m into x power n.
10 to the power of 7.
Correct? So 10 to the power of 7. So this will be 1 upon 10 to the power of 7 into centimeter square gram second minus 2 divided by centimeter square gram second minus 2. They both are same. So you can actually, it goes off. So your x is equal to, so what you are having, so from here you can write your x is equal to 1 upon 10 to the power of 7, or that is equal to 10 to the power of minus 7. Okay, so a CGS system, a CGS energy is connected to the SI energy by 10 to the power of minus 7. Correct? What is the CGS unit of energy? Tell me. What is CGS of energy? CGS is erg. Am I right? SI is joule. So therefore 1 erg will be equal to 10 to the power of minus 7 times of 1 joule. Okay, so you are getting the conversion is, so how to convert CGS system, erg, so what the calculation you have done in CGS or your co-worker has done in CGS and you have done in SI, how we are going to connect them. So now you know the number by which it is going to connect. So what you have, so 1 erg equal to, that is because it is CGS, right? CGS unit is erg, correct? 1 erg is equal to x is equal to 10 to the power of minus 7 times, and SI system is joule. Or you can write it reverse also. 1 joule equal to, tell me, 10 to the power of 7 erg. Either of the way you can.
Divided by 10 to the power of 7.
Correct, 10 to the power of minus 7. So that will become 10 to the power of 7, na? Correct? Yeah, see, this is what? This is what? 1 upon 10 to the power of minus 7 erg. Correct? 1 upon 10 to the minus 7 is equal to what? 10 to the power of 7 erg. You got it? So your dimension analysis also provide you the unit conversion. Okay? And this is the only way you can actually convert the unit using the dimensions. Okay? So these are the 3 important aspects of this dimension analysis. Okay, and then there are some problems given in your book. We have to do all the problems. Some other time we will do the problems. Okay, even earlier also there are many problems. We have to first, you have to try those problems and then I will. If you have any problem, then I will do it. Okay, so and then there are, okay, so this dimension analysis also, it's a very, initially I forgot to tell you one thing. So when you are checking the correctness of equation, okay, if you remember, I would have said that. So what happened? I told you from the 10th floor you are dropping a stone. Am I right? And you are asking at what time? Okay, at that time, at 2 seconds, what is the distance that traveled by that stone? Okay, so now instead of dropping the stone, if I throw the stone, that means I am going to give an initial velocity, correct? So then my S will be ut plus half at square, correct? So I said when I drop, this will become 0. But if I throw it, then there is some initial velocity, so this cannot be done. So when you have an additive quantity, now if you actually, additive quantity, if you see, so your left hand side is distance. So right hand side also should have the distance measure, dimension of a distance. Okay, but when you have additive, both of them individually should have the same dimension. Remember that. So that means what? So what is the dimension of S? There is a distance. Tell me. L1 M0 times 0. Correct? So what about UT? I will write directly. Okay. U is what? Velocity. Am I right? Velocity is what? Meter per second. So LMT. So meter, that means length is 1, mass is 0 per second. So minus 1. And T. And next one is what? T. T is time only. So 0, M power 0, T power minus 1. So when you multiply what this two will have? Tell me. L1, M0.
There should be 1.
Oops, sorry, this is 1, right? This is 1, right? This is 0. Are we getting the same dimension? You got it? So see, this is getting the same dimension. Let us go for the second term also. That is AT square. I am leaving 1 by 2. You know what is 1 by 2 is, right? AT square already we checked earlier also. We saw it. And that's what the acceleration is equal to meter per second square. That means LMT meter. Meter is length. 1. No gram mass is 0. Meter per second square. Per second square. That means minus 2. And T square is LMT. L is 0, no length, no mass. T is equal to 2. So what will be the product of these two? L1 M0 T0. You got it? This is also again same with that. So when you have addition of these two things, when you have addition of these equations, both the terms individually, these terms should have the same dimension. That's one of the important tests. Whenever you are doing any equation, if you have any two quantities adding, if these two quantities have a different dimension, surely you are doing some mistake somewhere else. You got it? The second thing is whether that dimension is matching with the LHS. That's the second part. The first part is in the RHS itself. If different terms has different dimensions, that means surely you are doing some mistake. Okay, so these are all the easiest step to find out. And fine. Okay, so let us then what we are going to. So this dimension analysis is one of an important and interesting tool which can be used to which can be very useful in your physics. Okay, but there are certain limitations also. What are the limitations? First one, so the book has given some 2-3 limitations. Yeah, see, first one, because see, as I told you, from the intuitively you can get from the intuition you can derive an expression for the actual physical formula, what we saw in the pendulum. But that is not complete, because always there will be a proportionality constant. And the proportion, how to find a proportionality constant? Then you have to do the experiment. So dimension analysis is not a complete, it is incomplete. It gives you just a start. Okay, beginning. So that's the one part. Second part is, second part is important. See, that's a very important drawback of the dimension analysis. Suppose if your equation has some sine theta, your actual equation, suppose we got L by G, square root of L by G, very easily we took a simpler problem and we solved. Suppose if you are taking up some physical process and you are solving it out, okay, and you are solving using dimension analysis. Now, if you do an exact calculation, starting from equation of motion, you do everything, you do the equation of motion and everything, if you do the exact calculation, and if there is a term something like sine theta, in dimension analysis, you will miss that sine theta, because sine theta is dimensionless. You got it? What is sine theta? Sine theta is the opposite side by hypotenuse. You call that also length, this also length. Okay, doesn't have a dimension at all. You got it? Sine theta, any trigonometric ratios, tan theta, sine theta, whatever. If your actual equation contains any of these trigonometric ratios, by your jugglery of making a pendulum problem, you will miss those things. Okay, so that is one of the drawback. You will not be able to get those trigonometric functions from the dimension analysis. You have not read logarithm, right? So you will see logarithm is one quantity mathematical expression to use it out. Even that also. Because sine theta, the logarithm, these quantities doesn't have a dimensions of their own. You got it? So they are dimensionless quantities. If your equation contains those terms, your dimension analysis is going to fail. Okay, this is one of the important part. And the other one is, correct, that's one important thing. See, the dimension analysis says, what we did is, we took the, we wrote it proportional to all the important quantities, we understood that, and then we put it as take a constant and we did it. We missed one thing, and that constant, we took the constant doesn't have any dimension. Am I right? Suppose, for example, let us take Newton's law of gravity. What is the force? The force between two bodies in the space, the force of attraction, what is Newton's law of gravity? Every two body in the universe will attract each other. That's why we are sticking to Earth. Okay, because Earth is attracting us. Okay, and what will be the magnitude of that force? The attractive force will be proportional to product of their masses and divided by the square of the distance between them. Am I right? So you can, apparently you see, wow, this is very interesting. I can always solve this problem by the dimension, correct? No, if you check the dimension, right hand side and left hand side dimension will not be there. This dimension is not equal to the dimension. So these two dimensions are not equal to. Okay, the reason is because then this proportionality is removed by a gravitational constant, G. You remember, I think this is in 9th standard, am I right? You got in 9th standard, right? 8th or something. So force is equal to gravitational constant m1 m2 by r square. Okay, this has a dimension. This is not a dimensionless quantity. Okay, the moment your proportionality constant, when it has a dimension, so similarly you can say the force of attraction between two charges. There are many cases like that. Okay, they all will have once this proportionality constant, when they have a dimension, then you can't use the dimension analysis. The dimension analysis can be done only when the proportionality constant is dimensionless, like in our problem of a simple pendulum. Okay, so this is the other one. And yeah, that's another thing. See, that's what now. See, I wrote that equation already, and that will be interesting. What I said, as I put up the problem, I'm dropping the stone from the 10th floor. I'm throwing it, and I'm asking you. I'm dropping the stone, and I'm asking you the time distance at a different time. You can easily do it. You can use it. That also you can solve by dimension. Huh? I did the pendulum, na? So you can also do the same thing. I leave it for you to do it. You take a stone, drop it. You don't know any laws of motion at all. Okay, what will you do? You dropped it. So you know what are the things, what are the quantities? Mass of the stone, it may happen. Acceleration due to gravity, correct? And what is the height? Okay, these three quantities are the one which is going to decide how long it is going to take the time. Correct? The mass of the stone and the time, the height and the acceleration due to gravity. Acceleration. These three are the quantities. If you do, you will see again the mass power will come out to be 0. Okay, so mass power will come out to be 0, so that will be independent of mass. It will be there. Okay, and but if I not dropping it, I am throwing it out. Then what will you do? You write V also. Then what you will write? You write your S will be equal to, S is proportional to the height from which I am going to drop. So h power A. Okay. And what is the gravity? G power B. Okay. And then what's the leftover? Mass. Correct? Mass power C. And then I am going to drop an initial velocity. Correct? So that I am going to write it V power D. If you try to do this dimension problem, you will get it wrong. Because why? Your actual equation, when you try to do the actual equation, your actual equation S is equal to ut plus half at square. Because u is not that, sorry, this is a u. Okay, I wrote it as u, I wrote it as v here. U, that's the initial velocity. Am I right? So we have wrongly written u as a product of all these quantities, but u comes as a additive. Okay, under these conditions also, so a dimension analysis can fail. Okay, so these are the limitations of the dimension analysis. However, so this is one of the very easiest and important tool in physics by which most of the physical problems, even advanced research problems, okay, so even many Nobel Prize problems are also attempted using this dimension analysis. Okay, so well, with that I stop this dimension analysis. In the next class, we will see about something other interesting thing, that is accuracy, precision and uncertainty measurements. That's something interesting. We will do that. Okay, and that we'll see it in the next class.